Next is rectifier. So what is rectifier? Rectifier is a device which converts the bidirectional AC into a unidirectional DC, that is called rectifier. So in rectifier, the first type of rectifier is half wave rectifier. See this circuit here of a half wave rectifier in which there is a AC input of 230 volt 50 Hz is given to this transformer, and this AC input is given to this primary winding of a transformer, and after that depends on the type of transformer, that is step up or step down transformer, the voltage across this secondary winding, that will be decided by this type of transformer. If it is step up transformer, then the voltage should be increased, and if it is step down transformer, then the voltage should be decreased. After that, to this secondary winding of a transformer, there is a diode is connected in series with this load resistance RL. So to the secondary winding of a transformer, there is a diode is connected in series with the load resistance RL, and across this load resistance RL we will take the DC output. That means this half wave rectifier, it will convert this bidirectional AC input into a unidirectional DC output. So this is the construction of a half wave rectifier. Now we will see the working of a half wave rectifier. Now see here, as the AC input is given to the primary winding of a transformer, this transformer, it will convert AC into a AC. So the output of a transformer is also a AC, and that output will be obtained across this secondary winding here, and we are considering the AC output across the secondary winding is V is equal to Vm sine of omega t, where this Vm is the peak value of this AC across the secondary winding of a transformer, and we can write here this Vm is equal to Vp is equal to the peak value of AC across the secondary winding of a transformer. The next point in this, during the positive half cycle, this terminal A is positive with respect to terminal B. This terminal B is negative. So as this terminal A is positive with respect to the terminal B, that means terminal B is negative, so this diode is in forward bias. Why? Because the current is flowing from the anode terminal of diode to the cathode terminal of diode. Because of that, the diode is in forward bias here. Diode is in forward bias. So as the diode is in forward bias, that means diode is conducting here and the current will flow through the diode through this load resistance RL to the terminal B here. So in a positive half cycle or during a positive half cycle, the current flows through the diode. That means diode is conducting here and diode is in forward bias. As the diode is in forward bias here, then there is a voltage drop. There is a voltage drop across this diode. Why? Because the current is flowing through this diode. Because of that, there is a voltage drop across the diode, and that voltage drop is small voltage drop. If we take a germanium diode here, then the voltage drop should be 0.3 volt, and if we take the silicon diode here, then the voltage drop will be 0.7 volt. So this voltage drop across the diode, this is called offset voltage. This voltage is called offset voltage. When the diode is in forward bias, then the current flows through the diode, and as the current flows through the diode, that current will also flows through this load resistance RL, and as the current flows through this load resistance RL, we will get the DC output. We will get the DC output during this positive half cycle, where the terminal A is positive with respect to terminal B. So this is the working of a half wave rectifier during the positive half cycle. Now we will see the working of this half wave rectifier during the negative half cycle. So during the negative half cycle, the terminal A here is negative with respect to terminal B. That means terminal B is positive. So as the terminal B is positive and terminal A is negative here, then what happens? The current flows from terminal B to terminal A here, and when the current flows from terminal B to terminal A, what happens? This diode is in reverse bias here. This diode is in reverse bias. So as the diode is in reverse bias, so there will be no current flows through the diode. So as there is no current flows through the diode, then what happens? There will be no DC output across this load resistance RL here. So during the negative half cycle, as the diode is in reverse biased here, so there will be no current flows through the diode here. So there will be no DC output across the load resistance RL. So during positive half cycle, we will get the DC output across the load resistance, but during negative half cycle, there will be no DC output across the load resistance RL. Now we will see the waveform of this half wave rectifier. See here, this is AC input, and in this AC input, this is positive half cycle, this is negative half cycle, this is a positive half cycle, this is a negative half cycle. Now as we already seen that during the positive half cycle, the diode is in forward bias and the diode is conducting here, so the current flows through the diode. So we will get the DC output across the load resistance. So see here, during the positive half cycle of AC here, we will get the DC output here. we will get the DC output. But during the negative half cycle, the diode is in reverse bias, so that the diode is not conducting. So there is no DC output across the load resistance. So during the negative half cycle, we will not get any output here. We will not get any output here. Again, during the positive half cycle, the diode is in forward bias, diode is conducting, so we will get the DC output across the load resistance RL. So we will get the DC output here in this waveform. Again, during the negative half cycle, diode is in reverse bias, so there is no DC output here. So this is the waveform of a half wave rectifier, and it shows the working of half wave rectifier. Next is the average voltage, and this average voltage is also called as the DC voltage, because it was a DC output across the load resistance RL. So this is the DC output across the load resistance RL. So this is called as the average voltage as well as DC voltage, and it is denoted by VDC here. So this VDC, that is the average voltage, average DC output voltage, that should be equal to Vm upon pi, or we can write it as Vp divided by pi here, because Vm is equal to Vp, that is a peak value here. So this is the formula to find the average voltage across the load resistance, of a half wave rectifier. Next is the current rating of diode, and this current rating of diode is denoted by IO. So what is current rating of diode? How much direct current the diode can handle. How much direct current the diode can handle is called current rating of diode. Next is the peak inverse voltage. This peak inverse voltage is also called the PIV. Now see here, during the negative half cycle, the diode is in reverse bias. See here, during the negative half cycle, the terminal B is positive with respect to the terminal A. That means terminal A is negative. So the diode is in reverse bias. So when the diode is in reverse bias, what happens? All the secondary voltage that appears across the diode. So during the negative half cycle, diode is in reverse bias, so all the secondary voltage that appears across the diode, and this secondary voltage is called the reverse voltage. This secondary voltage is called the reverse voltage. So this maximum reverse voltage, the diode can withstand with. The maximum reverse voltage the diode can withstand with is called the peak inverse voltage is called the peak inverse voltage. So see in this figure here, the maximum voltage across the secondary winding of a transformer is Vm or Vp. So if we consider Vp is the maximum or a peak voltage of a secondary, this secondary voltage appears across the diode during the negative half cycle when the diode is in reverse bias. So this is the maximum reverse voltage the diode can withstand with. So Vp is what? It is the peak inverse voltage. It is the peak inverse voltage. So at this peak inverse voltage, there is a possibility of breakdown of a diode. So to avoid this breakdown, the PIV rating, of a diode is greater. PIV rating of a diode is greater than this peak inverse voltage, and this peak inverse voltage here, that peak inverse voltage is Vp. So to avoid the breakdown of a diode, the PIV rating of a diode should be greater than the peak inverse voltage. So this is all about the peak inverse voltage. Next we will see the advantages of a half wave rectifiers. The first advantage of half wave rectifier is only one diode is used and the normal transformer is required. The second advantage of half wave rectifier is the circuit of a half wave rectifier is simple and it having a low cost. The third advantage of half wave rectifier is the peak inverse voltage. The peak inverse voltage is only Vp here. The peak inverse voltage is only the Vp, that is the maximum or peak value of voltage across the secondary winding of a transformer. So these are the advantages of half wave rectifier. Next we will see the disadvantages. The disadvantages of half wave rectifier. So the first disadvantage of half wave rectifier is the output of a half wave rectifier. The output of a half wave rectifier is less. Why it is less? Because the output of a half wave rectifier, we will get that output during only one half cycle. Here we are getting that output during this positive half cycle here. So because of that, the output is less, and that output, that is VDC, is equal to Vp divided by pi, or we can write this as Vm divided by pi. So the first disadvantage of a half wave rectifier is the output is less. The second disadvantage of half wave rectifier is there is a wastage of the negative half cycle. There is a wastage of the negative half cycle. So this is the second disadvantage of half wave rectifier. The third disadvantage of a half wave rectifier is, as the ripple frequency is low here. Because of that, there is a more ripples. There is a more ripple appears that results in a poor quality. That results in a poor quality DC. So the third disadvantage is as the ripple frequency is low here. So because of that, there is a more ripple and that results in the poor quality of DC. So these are the disadvantages of half wave rectifier. Next is the ripple factor. So see here first, what is ripple? Ripple is what? Ripple is unwanted fluctuation. Ripple is unwanted fluctuation. That means ripple is what? It is the part of AC in DC output. Part of AC in a DC output of a rectifier. So see here, the output of the half wave rectifier is this. This is the output waveform of the half wave rectifier, and here this output is not a pure DC here. It is a pulsating DC. That means there is a part of AC in this DC output. So this part of AC in a DC output is called ripple. So ripple is what? It is unwanted fluctuation, that is the part of AC in a DC output of a rectifier. The ripple frequency is same as the frequency of AC input, and here we are getting the output during only a positive half cycle. So in case of a half wave rectifier, the ripple frequency, that is denoted by this Fin, is equal to 50 Hertz. So in half wave rectifier, the ripple frequency is equal to 50 Hertz. So what is ripple factor? Ripple factor, it is the ratio of ripple factor. It is the ratio of RMS value of AC. That means the AC voltage in RMS, that is the RMS value of AC, to the DC voltage. That means DC output voltage. That is called ripple factor. So ripple factor is what? It is the ratio of AC voltage in RMS, that is the RMS value of AC, to the DC output voltage, that is DC voltage. Next is percentage ripple. So percentage ripple, we can find that percentage ripple as, that should be equal to the ripple factor into 100. So the percentage ripple is equal to the ripple factor into 100. So this is all about the half wave rectifier.